So I'll also be talking about causal reasoning, and I, in my heart of hearts, am an engineer, and I like to build products, and so I'm thinking about many of the things that Dr. Pearl just talked about in terms of how we're going to actually build artifacts that we can deploy to production and apply to powerful use cases, and that we in a business. My prediction is that probabilistic programming will be key to addressing AI's challenges with causality. And so probabilistic machine learning gives us a unified approach to reasoning and decision-making under uncertainty. Probabilistic programming languages enable you to build probabilistic machine learning models by writing programs, writing software that represent probability distributions with general purpose programming languages. And they also give us abstractions for reasoning about these models using data and making predictions and decisions. And modern probabilistic programming languages build on deep learning and automatic differentiation to scale probabilistic machine learning to large, high-dimensional data sets with nonlinear relationships between the variables therein. And so one of the reasons I make this prediction is because first off, there's a very natural connection between probabilistic programming and causal modeling. So users of probabilistic programming languages typically write models that explicitly represent the causal flow of the process that generates the data. Secondly, probabilistic programming languages have their roots in Bayes nets, where causal inference is a common use case. We have some eminent, cognitive scientists on this panel today. Computational cognitive scientists use probabilistic programming and develop probabilistic programming languages to model how humans generate causal explanations. And finally, it's very closely related to computer simulation, where this is a field, particularly in engineering and natural sciences, where we directly model mechanism. And so we can also use probabilistic programming for formal causal inference. So probabilistic programming languages can implement the well-defined formal causal models, such as structural causal models. We're also developing formal methods to extend these to a broader, more expressive class of causal programs. Probabilistic programming gives us an intuitive way to combine causal assumptions with the kinds of inductive biases that we like to see in machine learning, that we rely on in Bayesian modeling. And probabilistic programming can happily adopt the deep neural network architectures as components in a larger causal structure. So finally, it gives us the ability to make learners that can reason counterfactually, right? So some of the more popular languages like Pyro, Omega, Multiverse, they enable algorithmic counterfactual reasoning. And this enables us to build agents that can reason by generating counterfactual explanations, much as humans do. So this is something that's near and dear to my heart. I've spent a lot of time building conversational AI, and what you want is to have a bot think of an appropriate thing to say to a user, and then ask if it's, or somehow get some feedback whether or not that was a good thing to say. If not, then it should imagine, or to use Dr. Pearl's, I think you just said, if only I had said something better, I would have gotten a better outcome. And then you can kind of imagine what other things it could have said, and then update its policy for how to interact with that user. I want to point people out to this GitHub repo, where you can find some video tutorials and some code tutorials. And also, if you're interested in this field, here are some papers to get you started.
All right, thank you.